This section is, again, directly related to calculus. We're going to be talking about extrema and average rates of change, and the wording and the notation is directly from calculus. So you're going to be doing it all over next year, okay? But in a calculus context. So right now we want to talk about functions. So when we look at functions in this context, we look at the function, we read it from left to right. So if you look at this function, starting at the left and going to the right, the function is increasing, right? It's moving upwards. So if you were on this roller coaster, you would be going up. So we say, okay, we don't say it is going up. We say the function, or f of x, is increasing, okay? And usually when we talk about this, there is an interval associated with it. So we say it's increasing on the interval negative infinity to positive infinity, or, so this one is presumably going to go up like this forever. It's going to keep increasing. Okay, so you read it left to right. You read it from here in this direction, okay? If you look at this function now, this is decreasing, okay? So left to right, this is going down. We don't say going down, we say the function, or f of x, is decreasing on the interval, okay? And again, there is usually an interval associated with it. Now, look at this one. You see in this region, it's decreasing. Here, it stops to decrease, but here it picks up again and it's decreasing. But what's happening here in the middle portion? In the middle portion, it's flat. The mathematical word or term for it is constant. So we say the function, or f of x, is constant. Okay? Not flat, but constant. So there is no change there. Well, the function on this interval, a to b, is constant. Okay, so it's either increasing, decreasing, or constant. Let's apply it to this problem here. So we want to determine the intervals on which the function is increasing, decreasing, or constant. Yeah. What we're going to do first, okay, is just look at this. You see how this is increasing and then it starts to decrease, and then it's increasing and then it's constant. So now we want to split it up into the intervals where this change is happening, okay? And then there's another change here. So I'll do the first portion. It's increasing, okay, on the interval. Now, presumably, this is going to be going down forever. So if we're looking at it from left to right, it's increasing from negative infinity. You're always looking at the x's, okay, the x value. So from negative infinity all the way to x equals negative 3, okay? So from negative infinity to negative 3, it's increasing. When we're talking about increasing and decreasing, it's always parentheses, never brackets. We never include those exact points because you'll learn in calculus later that something else happens at those exact points. That's why they're always open. Okay? So now afterwards it starts to decrease. So now I'm going to say, all right, it decreases from what to what? It's decreasing in this region. So from what to what? Negative 3 to 2. And then it's increasing again, right? From where to where? 2 to 6. So here I just continue in the first line. Union 2 to 6. Okay? You combine them. Here. Here 2 to 6. It's increasing, right? From x equals 2 to x equals 6, it's increasing. That's the y value. Then it's constant starting at x equals 6 and going to positive infinity. Always open intervals. Okay? Because we're not talking about domain here. We're talking about increase, decrease, always open intervals. All right? So that's pretty much how we state that. Let's do another example here. This is an x cubed function. Okay? Again, estimate to the nearest half unit. So in the case of this one, it'll be increasing from where to where? Everywhere, from negative infinity to positive infinity.
Isn't it also decreasing?
So this is the x cubed function, right? So it's going to be expanding slowly but surely to the right this way and to the left this way. It's increasing from here to here. So from negative infinity to positive infinity. Okay? So where is the leftmost part? Here. And it's going to keep expanding. So if you read it from the left, it's increasing everywhere. Okay? What about this one? Here's where a change happens. Right, so it decreases. What is the interval on which it decreases? Negative infinity to 2. It's decreasing in this region. Okay, and then where is the interval where it increases? 2 to positive infinity. Oops. Okay. The next one is a piecewise function, but that's fine. So first it's increasing from where to where? Negative infinity to 0. Where else is it increasing? From 3 to infinity. And it's constant from 0 to 3. So just remember that you're always taking the x coordinates. Okay? It's an interval over the x's. What about this next one? It's increasing from negative infinity to where? Negative 1. And again from positive 1 to positive infinity. Right? So look, if you initially, later on you will definitely get the hang of this, but initially if you do little marker lines like this, then you will know to take these regions. Okay, so this one, and this one. Okay, so always the x values. So right, so where is it decreasing? Negative 1 to 1.
You can just do it if there's like, if there's only 3, like with those two, you take so like that was 0 and 3.
Right, you take the balance. Now, extrema. We've talked about maxima and minima, right? Where is the maximum? Where is the minimum? Together, in general, those points are called extrema. So an extremum is either a maximum or a minimum. All right, it's the extreme points. Now, there is a differentiation between relative and absolute extrema. So of the maxima or the minima, okay, the highest peak is always called absolute maximum, and the lowest valley is always called absolute minimum. Okay, so this is absolute max, and this is absolute min. Please remember that in order for it to qualify as a max or min, it has to be a peak or a valley. All right? So for example, if you have a graph that looks like this, and it ends here, right? Here you definitely have a maximum. And then students will tell me, well, wait a minute, that's a point that's even higher But no, in order for it to be qualified or classified as a maximum, it has to be a point where it turns around. Okay? Mathematically, that's how it's defined. All right. So you have the absolute max and the absolute min, and everything else is either a relative max or a relative min. Okay? So if a relative min or a relative max is the greatest value over its entire domain, then it becomes an absolute maximum. Okay?
Can you say that again? Sorry.
If a relative maximum is the absolute highest point, then it becomes an absolute maximum. It's this wording here. Okay? It's in the chart. Sorry? Right. So if that's an absolute max, then this is a relative max. If this is an absolute min, then this is a relative min. Okay? All right? Now, estimate and classify the local and absolute extrema of the graph of this. So,
There can be two absolute.
right.
And it's just -1. No, but it's.
So here and here,
There's only one though.
okay, here and here, you have minima. Okay? Sorry?
The same thing as relative, right? Local.
A relative, right. Right. Well, okay, so now if in this case, whether you say relative or absolute, it wouldn't make too much of a difference. It's probably more correct to say absolute minimum. And we're going to write them in our usual notation. So it's f of -1 equals -1, and f of 1 equals -1. And we have an absolute max. F of 0 equals 3.
So it doesn't matter if their graph goes higher, just the
Yes.
highest value.
Right. For it to, it has to be either, it has to be a point where it turns around. Okay, so let's do some more and you'll see the difference. So here there is an absolute min. F of what? It's this point, right? So f of -1, 2, 3 equals -4. All right, here. We have several points. So, well, okay, so look at this one. This is an absolute min. And this is the absolute max. Okay? What we're going to do for this one is plug this equation into our calculator. Okay? So, x to the power of 5 minus 2 x to the power of
Whoa.
X comes in section.
in a case like this where you graph, and if you're not given the graph on your test or wherever and you're graphing on your own, the windows that I have right now are really not very convenient for this. Okay, so it's better if I go into window and modify them. Okay, so I have, for example, -5 to 5 here and -5 to 5 here. Okay? Now when you graph it, you get a much more accurate representation of what's happening. Okay? And you can go in and, using your second calc feature, you can find the value. So what is the value for the absolute max?
F of negative 1 equals 2.
F of -1 equals 2.
Yeah. But for the absolute min, I don't think you can.
Absolute min. What about the absolute min? No. Okay, but not the other ones though. You don't. Okay. Because it's not exactly. Look at it very, very closely. Is it exactly on the corner?
Either it's